It's called conic sections. Aw, man.
What's that?
Well, I brought in some special friends to show you. But first, a conic section is a curve determined by the intersection of a plane with a double right cone. Huh?
You will find out soon enough.
Now Jose will tell you about some circles.
This is Jose. Hi, Jose.
Hi, kids. I'm sure you have seen or heard of a circle. A circle is the set of all points in the plane that are equidistant from a given point in the plane called the center. The distance from the center to any point on the circle is called the radius. The standard form of the equation of a circle with a radius r and center at h, k is x minus h squared plus y minus k squared equals r squared.
How do you find the general form of the equation?
First, you must FOIL the x minus h squared and the y minus k squared to get to x squared minus 2hx plus h squared plus y squared minus 2ky plus k squared equals r squared. Since r, h, and k are constants, you can let d, e, and f equal negative 2h, negative 2k, and h squared plus k squared minus r squared. Then that is shown as x squared plus y squared plus dx plus ey plus f equals 0, which is general form.
Thank you, Jose. That was lovely.
Next, we're going to go for Sally, and she's going to talk about ellipses.
Let's all welcome Sally the sheep, who's going to talk about some ellipses.
Hi, kids. An ellipse is the shape of an oval. Does anybody know what an oval looks like? Very good. An ellipse looks like this. An ellipse is another one of those conic sections we mentioned earlier. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points. Those 2 points are called the foci, and you can see them right here and here. The equation to find the foci is h plus or minus a, comma k, and then h, comma k plus or minus a. An ellipse also has 2 axes. One of them is called the major axis, and the other is called the minor axis. The center point is h, comma k. An ellipse either has a standard form or a general form. The standard form in an ellipse is x minus h squared over a squared plus y minus k squared over b squared, and that's all equal to 1.
Then, for the major axes, that is y equals k. The major axis vertices are h plus or minus a, k. The minor axis is x equals h, and then the minor axis vertices are h, k plus or minus b. And to convert an ellipse in general form, which is ax squared plus cy squared plus dx plus ey plus f equals 0, you must first
Find the greatest common factor of the x terms and the greatest common factor of the y terms. Once you have that, you can go through the process of completing the square.
But note, don't forget to multiply both sides by the factored out coefficient. Once you have completed the square, you must factor out the binomials. Then, you must divide both sides by whatever is to the right of the equal sign. And don't forget to simplify.
And there you go. You have your answer in standard form.
That was Sally the sheep. Thanks, Sal. And now, Ralph is going to talk about something special. It's hyperbolas. Bum bum ba.
Welcome, Ralph.
Hey guys, a hyperbola is a set of all points in the plane in which the difference of the distances from 2 fixed points, called foci, are constant. Now there are 2 kinds of hyperbolas, vertical ones and horizontal ones. For a horizontal hyperbola, the main parts are the center hk, the foci h plus or minus ck, the vertices h plus or minus ak, and the transverse axis y equals k. The standard form for this is x minus h squared over a squared minus y minus k squared over b squared equals 1. Hyperbola opening vertically, the main parts are the center hk, the foci hk plus or minus c, the vertices hk plus or minus a, and the transverse axis x equals h. The standard form for this graph is y minus k squared over a squared minus x minus h squared over b squared equals 1. In both these cases, b squared equals c squared minus a squared, where a is the distance from the center to a vertex, and c is the distance from the center to a focus. Hyperbolas are unique in that they have a set of lines that they approach but never cross, called the asymptotes. For a horizontal asymptote, the equation is y minus k equals plus or minus b over a times x minus h. For a vertical hyperbola, the equation is y minus k equals plus or minus a over b times x minus h. Conic sections. Hyperbolas have a general form as well. To convert from standard to general form, we first multiply by a squared and b squared to get rid of the denominators. Then we can FOIL the terms that are squared. After that, we distribute the coefficients so that we have the coefficients. And then after a little bit of moving around all the terms and substituting for the constants, we have general form.
Great job, Ralph. Now next is Shelby, and she's going to talk to you about parabolas.
Hey everyone, these are parabolas. A parabola is defined as the set of all points in a plane that are the same distance from a given point, the focus, and a given line, the directrix. Parabolas are a little bit different than the other kinds of conic sections. For starters, parabolas have only one vertex instead of a center. It's still located at HK, but we don't call it the center. There are two kinds of parabolas that I'm going to tell you about. The parabola on the right side of this diagram is a picture of a parabola lying on its side, or a horizontal parabola. A horizontal parabola can either be open to the left if the sine of p is negative, or to the right if the sine of p is positive. For a horizontal parabola, the standard form is y minus k squared equals 4p times x minus h. And the general form is y squared plus dx plus ey plus f equals 0.
That's a good job.
Just like other conic sections, parabolas have a focus, and a horizontal parabola, it's located at h plus p k. All parabolas also have two invisible lines on their graphs called a line of symmetry and a directrix. The axis of symmetry for a horizontal parabola is located at y equals k, and the directrix is at x equals h minus p. The other type of parabola is a vertical parabola, and the one on the left in my picture. A vertical parabola looks like an umbrella, and it is either like a normal umbrella if the sine of p is negative, or it looks like an upside-down umbrella if the sine of p is positive. The standard form for a vertical parabola is x minus h squared equals 4p times y minus k. And the general form is x squared plus dx plus ey plus f equals 0. For a vertical parabola, the focus is at h, k plus p, and the line of symmetry is at x equals h, and the directrix is at y equals k minus p. With parabolas, converting from standard to general form is really easy. Here are some helpful steps to do it and an example. Start with your equation. Step 1. FOIL the left side of the equation. This just means that you multiply out the square. Step 2. Distribute the 4p on the right side of the equation. Step 3. Add or subtract terms to get all of the non-zero numbers on the left side of the equation. Step 4. Combine like terms. Step 5. Rearrange the equation to look like normal form, multiplying and dividing as necessary. And there, you're all finished.
Great job!
Everybody should give a great round of applause to all of our special guests. Woo! They all did a fantastic job of teaching you about conic sections. Now, does anybody remember what you learned? Oh, well, if not, there's a test on Friday. Don't forget to study.